Hi, this is Sambasam, Assistant Professor, National College of Technology. I welcome you for another session, another topic about what is the importance of robot joins. Now, I like to share the presentation with a recap of the previous sessions, right? The previous sessions, we have to discuss about various topics and various things. Right? So the previous topic is about what is meant by robotics and reprogrammable multifunctional manipulated design to materials, parts, or tools or specialized devices through variable programmed motions for the performance of a variety of tasks. Then moving towards loss of robots, the Asimov's laws of three laws don't harm humans, obey the human order, and it has to protect by itself. Then the history of robots and the evolution of industrial robots and robot autonomy, like what is it is manipulator, end effectors, actuators, sensors, controllers, and softwares. These are the things where we have discussed in the previous classes. Now we are moving towards an industrial robots and what is the applications of industrial robots. Also, we have discussed right. So apart from the different type of robot configurations like Cartesians, polar, cylindrical, and giant arm, along with the scalar robots. These are the different type of robots. So these are the basic sections we have discussed in the previous in a detailed manner. Now we are going to discuss about the different type of joints. So there is a five different type of joints. One is a linear joint, another one is orthogonal, rotational, twisting, and revolving joints. As I said, in the name itself, we can able to understand what is the purpose and what is the main need of these joints. We can able to describe that. So the name itself, we can able to see the linear joint, right? So what is the purpose of joints in robots? Everybody has to know, right? So these how the human joints, hand joints or leg joints or neck joints or shoulder joints are is there. So to do a certain performances, whether it has tends to move or not. So this type of elbow joints, these rotation joints, and the head can be moved, but we don't have this 60 of rotations. But instead of robot, it has a 360 rotation without affecting their wiring structures. So now moving towards the joints and linear joints, the name itself shows there is an linear movements only. So the joint motion is left to right or up and down. So the GIF, these L-type joints, the relative movement between the input link and the output link is a translation sliding motion with the axis of the two links parallel. And then moving towards orthogonal joint. Orthogonal joint is like cylindrical robots. Like it has a one rotational movement. In the name itself, orthogonal. Then the type of joint is said to be an O-type joint. So the relative movement between the input link and the output link is a translation sliding motion, but the output link is an perpendicular to the input link. So the T has been translate rotation and the L and O is movement on linear versions. And the third one is an rotational movement. The rotational movement shows and the GIF file shows this is an odd type where it makes a 360-degree of rotations where this type of joint is said to be an R joint. This provides a rotational relative motion with an axis of rotation perpendicular to the axis of input and output links. Then moving towards twisting joint, right? What do you mean by twisting joint? The picture itself shows the movement of twisting, right? This is to be a deep J joints. This provide rotary motions, but the axis of rotation is parallel to the axis of the two axes. So it is similar to our arm joint. So it has tends to move like L shape, where we can able to twist arm. The final one is revolving joint. This type joint is not a V. By in the name we cannot say it is a V type of joint where it has to move based on how it has been moves according to the situations. So this axis of the input link is parallel to the axis of rotation of the joint and the axis of the output, and the link is perpendicular to the axis of the rotation. So these are the different type of links. Apart from my video, that I have showcased some other video links to clear visible views for your things. So without this type of joints, we cannot manipulate or we cannot perform a certain task or movement the task from one place to another. These important things is these joints suppose the movement of movement of robots based on their configuration requirements. Without the engines, the robot cannot be designed. This is the different type of joint mechanisms used in robotics. Hope everybody is understand. With this note, I like to signing off. This is Samson, Assistant Professor, Essence College of Technology. Till that, meeting in the next video. Till that, bye bye. Thank you for watching this video.